In this video, let us see bilinear transformation. The definition is the transformation W is equal to AZ plus B by CZ plus D is called as bilinear transformation, where A, B, C, D are complex constants here, such that AD minus BC should be not equal to 0. So this transformation is called as bilinear transformation. And this transformation is otherwise called as linear fractional or Mobius transformation. Okay. Next, coming to the definition, invariant point or fixed point. So what is the definition of invariant point? The image of a point Z under a transformation is itself. That is, under the transformation W is equal to f of Z is itself, which means that we are considering a two plane, Z plane and a W plane. So the image of the Z plane will be in the W plane. So when we can say a point is an invariant point is image of a particular point in the W plane is itself. Okay. So here as an example here let us see the first example how to find the invariant point of the transformation. So W is equal to 1 by Z minus 2I is the given question. So here for this transformation, actually this is the bilinear transformation. So let us take the first question. So for this bilinear transformation, what about the invariant point or how to find out the invariant point? Since according to the definition of invariant point, the image of a point of Z under the transformation is self, which means that W is the image of Z, so which is equal to Z itself, which means that W should be replaced as Z here. So that here what we can do, this W can be replaced as Z, so 1 by Z minus 2I. So on simplification, we can cross multiply this. So this becomes Z into Z minus 2I is equal to 1. So if you simplify further, we can get a quadratic equation like this, that is Z square minus 2iz, and then right side 1 can be taken as minus 1 to the left side. So this is of the quadratic equation. So we can solve this using the formula what? Minus b plus or minus root of b square minus 4ac divided by 2a. This is a usual formula I have studied to solve the quadratic equation. If the quadratic equation is of the form ax square plus bx plus c is equal to 0. So here finally we can have z minus I whole square is equal to 0. Either you can use the formula or otherwise we can factorize like this. So if we factorize, we can have z minus I whole square is equal to 0. Because if you expand it, it will give you z square minus 2iz is the second term and plus I square is the third term. I square is nothing but minus 1. So without using the formula also we can factorize this, which gives you z is equal to I. So z equal to I is the invariant point for the given bilinear transformation. W is equal to 1 by z minus 2I. Next, moving to the next question. What is the next question? W is equal to z minus 2 divided by z plus 3. So what we have to do here is this W should be replaced by z. So this becomes z equal to z minus 2 divided by z plus 3. So cross multiplying this, we will get z into z plus 3 is equal to z minus 2. If you simplify this, it will reduce to a quadratic equation like this, z square plus 2z plus 2 is equal to 0. Now using the previous formula, here we can use that formula. So that z equal to minus b plus or minus root of b square is 4 minus 4ac is 8 divided by 2a is 2. So here it is minus 2 plus or minus. Actually root of 4 minus 8 is nothing but minus 4, but root of minus 4 can be written as 2i because I is nothing but root of minus 1. So here we can write plus or minus 2i divided by 2. So throughout if we cancel by 2, final answer will be minus 1 plus or minus I. So here we are having two roots, that is minus 1 minus I and then minus 1 plus I. So for this transformation W is equal to Z minus 2 divided by Z plus 3. Z equal to minus 1 minus I and minus 1 plus I or the two invariant points. Okay, for this transformation, we are having two invariant points.